Hi everyone. Writing chemical formulas for ionic and covalent compounds is an important skill in the world of chemistry. Scientists, educators, and students all need to make sure that they're communicating effectively and correctly when discussing molecules in either verbal or written form. Being able to correctly write chemical formulas takes time, patience, and practice, and because of this, I thought I would offer some additional practice and explanations in order to help you with assignment 2B1. So let's get started. To review a portion of the Session 2 lecture, the periodic table is composed of metals and nonmetals. Nonmetals are on the right side of the periodic table, and metals are on the left side of the periodic table. Most elements on the periodic table are metals, as you can see. Ionic bonding occurs between metals and nonmetals in order to balance the charges of the ions and create a neutral compound. Covalent bonding occurs between nonmetal atoms in order to satisfy the octet rule and to form a stable molecule. When we write chemical formulas, we first need to distinguish which type of molecules we are working with. Once this is established, there are two distinct rules for writing the formulas of the molecule. Covalent compounds are fairly straightforward. They consist of nonmetals, and the formula follows the prefixes in the name. For example, here we have dinitrogen tetraoxide, 2 nitrogens and 4 oxygens. Ionic compounds can be a bit more tricky. The formula is the combination that causes the entire compound to have an overall charge of 0. This depends on the charges of the ions. Let's look at some examples of ionic compounds. One easy trick to learn for ionic compounds is known as the crisscross rule. Once you identify the ionic charges, you just swap them in order to write the formula. This ensures that the charges balance out to 0. For example, the aluminum ion has a +3 charge, and the oxygen ion has a -2 charge. This is determined by looking at the periodic table. When we crisscross the charges, we end up with 2 aluminum ions and 3 oxygen ions. Recall that the subscript indicates the number of each of the ions. The formula is called aluminum oxide. For barium and sulfur, you would do the same thing. However, if it's possible to reduce to lowest terms, then that must be done. For instance, here the formula can be reduced to BAS. Finally, the indium ion and the bromide ion can crisscross and give 1 indium ion and 3 bromide ions. It is not necessary to write the 1, so just leave the formula as INBr3. If you are using polyatomic ions, ions containing more than one atom, the rules are the same but have one additional part. If you have 2 or more polyatomic ions, then parentheses must be put around the entire ion and then the subscript added outside of the parentheses. In the case of magnesium nitrate, there are 2 NO3 ions, therefore parentheses are used and the 2 is placed outside, indicating 2 of the entire polyatomic ion. For your 2B1 assignment, you must correctly write the formula and write an explanation for how that formula was determined. An example of what the explanation would look like for magnesium nitrate is written here. I hope that this has been a useful re-examination of how to write chemical formulas, especially for ionic compounds. As always, if you need help or have specific questions, please don't hesitate to contact me via email at mvhchemistry@gmail.com. Thanks!